Hello. For our presentation for Real Life Orgo, we will be talking about THC and CBD. To start off with some basic facts, the THC's technical name is delta-9 tetrahydrocannabinol, and CBD's technical name is cannabidiol. They both have the same molecular structure, which is C21H30O2. As can be seen in the chart here, there are some differences between CBD and THC. CBD is federally legal as long as the THC content is less than 0.3%, whereas THC is regarded legal in several states depending on whether it is for medical or recreational purposes. THC provides a high, whereas CBD does not. Some other significant differences is the psychoactive side effects of THC, whereas CBD has very few. Moving on, another significant difference between the two is that THC is used to provide a high, whereas CBD does not, as well as CBD is used to ease depression, which THC does not. So to move on and tell you how it works, the difference between the two is that they're isomers, which affects the type of neurotransmitters that are released. The neurotransmitters relay the body's messages of pain, immune issues, stress, and sleep, etc. The structures are similar to the body's endocannabinoids, which allow them to bind to the cannabinoid receptors, which is called the CB1 receptor in the brain. The THC binds to CB1, as can be seen here in this diagram, whereas CBD barely, if at all, binds to CB1, which is why it's not considered a psychoactive drug. It activates the serotonin receptors and increases certain levels of the cannabinoid anandamide, which blocks the enzymatic breakdown of anandamide.
CBD and THC can be synthesized in many ways. It is most notably made naturally in the hemp plant, where it is used to attract pollinators and to prevent overheating. It starts here as a carboxylic acid, and then enzymes can convert it into either CBD through this path or to THC through this path. And this is most notably done with the hemp plant, but a similar process has been found to occur with some versions of yeast. Now, there are many versions of THC, all with their very different stereocenters and various R groups, also known as analogs. There are over 60 variants of THC, but the molecules used the most today is the delta-9 THC, which is right here, and its family member CBD, cannabidiol. For THC, there are dozens of ways to synthesize it, all with its various products and different R groups. They all have different reaction conditions, and they all have various yields and stereoselectivity. There are many chiral approaches here, but two I would like to point out here is the Diels-Alder reaction synthesis, where it undergoes reaction at this double bond, and then the Claisen rearrangement, which occurs at this oxygen. To convert from THC to CBD, it's a very simple proton transfer, where this oxygen's lone pair attacks a Lewis acid, and then a base breaks this carbon and oxygen bond. Water kicks off the Lewis acid, and you turn this oxygen here into an alcohol group, which is CBD. To chemically synthesize CBD, one of the most common ways to do it is through electrophilic aromatic substitution. Here, at molecule 17, this electrophile reacts at either the meta or para directing ring here. And if it attacks at the para position, then you get CBD right here. But there are also other products formed here that are just different types of CBD that we're not really interested in. For THC consumption, what usually happens is this carboxylic acid here through THCA is heated up at 105 degrees Celsius, usually with a flame, and decarboxylation occurs, turning this into THC, which can be inhaled.
As stated previously, weed is a controversial substance. Its components are highly regulated by the FDA, so the separation of CBD from THC is very important. This can be difficult, though, because of how close they are structurally. Through the combined efforts of weed enthusiasts and scientists, many methods have been found, including liquid chromatography, reverse phase chromatography, CO2 extraction, and the boiling off of the THC. There are benefits and drawbacks to each of these. Liquid and reverse phase chromatography use the different polarities of substances to break them up by putting them through a non-polar or polar solvent. The sample is put into the solvent and falls into its different components as they move at different speeds depending on their polarity. This separation allows you to track exactly what is coming out of the sample as you go. This is the most common method used in research labs today. Reverse phase chromatography is very similar to liquid phase chromatography, but its mobile phase is polar and its stationary phase is nonpolar. On to CO2 extraction. Scientists will create supercritical CO2 and mix it with the plant substance at a certain temperature and pressure to extract only the CBD needed. This is the method used by most industrial companies today. It is the most expensive method on this list, and it is the fastest. While it's not as precise as liquid and reverse phase chromatography, it gets the job done well enough to pass the FDA's regulations. Finally, boiling off the THC. The differing boiling points make it easier to separate THC from CBD. If you heat THC past its boiling point and keep CBD below it, the THC will boil off and the CBD will be left behind. This isn't the most effective method, as you have to heat THC past 157 degrees Celsius and keep it below 180 degrees Celsius, but it gets the job done and is more accessible to the average person. It is also not as precise as the other methods used.
And now we move on to applications and uses. First off, we are going to go about ways of consumption. Please note that this is only for educational purposes. One of the most popular ways of consuming CBD and THC is something that is popularized by pop culture and demonized by the media, and that is inhalation. You can inhale CBD and THC through things like bongs, pipes, joints, blunts, vapes, and pens. Another equally popular way is the use of edibles. With an edible, you can literally make anything. But the most popular things are brownies, butter, and essential oils. The final way of consumption is topical, and this comes in the form of sprays, creams, and patches. Please note that topical use is only for medicinal effects, and it avoids all psychoactive effects of THC. Next up, we have medical benefits. CBD research and THC research in animal models and humans have shown numerous therapeutic properties for brain function and protection, both by its effects on the endocannabinoid system directly and by influencing endogenous cannabinoids. Broadly, CBD has demonstrated anxiolytic, antidepressant, neuroprotective, anti-inflammatory, and immunomodulatory benefits. CBD decreases the production of inflammatory cytokines, influences microglial cells to return to a ramified state, preserves cerebral circulation during isochemic events, and reduces vascular changes. It also has been shown to be very helpful in reducing the amount of epileptic attacks to those diagnosed with Dravet syndrome. Delta-9 THC has also been shown to protect the brain from various neuronal insults and improve the symptoms of neurodegeneration. THC has also been seen to be a great appetite stimulant, sleep aid, and analgesic, and to some people even a source of pure joy, as shown by Snoop Dogg himself. To continue on with the neurodegenerative diseases, we have an example, Alzheimer's disease. Numerous applications for CBD and Delta-9 THC for neurodegenerative diseases are being evaluated for both symptom relief and as treatments for the underlying pathological changes of neuronal tissue. Both CBD and Delta-9 THC can function as an agonist and an antagonist on various receptors in the endocannabinoid system. In addition, a wide range of non-endocannabinoid system receptors can be influenced by both endogenous and phytocannabinoids. For example, Alzheimer's disease induced activation of cultured microglial cells, as judged by mitochondrial activity, cell morphology, and tumor necrosis factor release, is blunted by cannabinoid compounds. Another example is that CB1 agonism is able to prevent tau hyperphosphorylation in cultured neurons and antagonize cellular changes and behavioral consequences in beta amyloid-induced rodents. This can be seen on the picture at the right because that is quite the complex sentence. In the bottom brain, one can see the tau neurofibrillary tangles and the A beta plaques, and those have seemed to be reduced when using CBD and THC.
Okay, that brings us to the end of our presentation. I want to thank you for listening, and I hope that you better understand the differences between THC and CBD. Here's a list of our references that we use for this project.